Yeah, so Charlie and Kevin, thank you for the great warm-up and covering this stuff at high level, and even your prompting some of the things we're going to talk about. So yeah, my company is 6D.ai. We're a startup that's really building and solving a lot of the problems that Kevin and Charlie talked about the mirror world and the AR cloud. And what I really wanted to get into today was what comes next. What does this concept, how is it actually built and practically turned into products and things that customers want? So we are really changing how we're thinking about this concept and moving away from sort of these abstract terms and into something closer to like an operating system for reality. So this time I want to just talk through how our thinking's evolved, show some demos of what that means in practical terms, and then really have some time at the end for some questions. So anything that you see, any ideas that come up that make you wonder what I'm really talking about, feel free. I'll make sure there's some time at the end. So as someone who kind of was there with in the conversation with Ori where we came up with this idea of the AR cloud, I actually don't care about it anymore. It is seriously important, as Kevin was talked about. Everything that he's saying is true. Everyone cares about it because it is going to be this platform that everything is built on in this next wave. But as we've been out in the market over the last year, talking with customers, trying to figure out what are these use cases, how does this stuff get built, what are the technology problems that actually needs to be solved, they don't really care. They don't care about the AR cloud. They don't really care about AR, to be honest. They just have ideas, problems that they need to have solved, and they want to build great apps for their users to get some benefit from. So we've shifted, in terms of, not in what we're doing, but just in terms of how we're thinking about it and how we're talking about it and how we're describing it. And really, it's less about this sort of amorphous data set that sits up there in the cloud and sort of as a replica of the real world. And we're thinking about it in terms of APIs, APIs that understand reality. And the model, I guess, that we're thinking through, this sort of narrative of how the world's changing is that, 20 years ago, 10 years ago, from an applications point of view, an operating system was a set of APIs that said, I need to be able to connect to the hardware and talk to the hardware and also to the user interface. And that was, touch screens on phones or the mouse on your Windows machine. And then the web came along and all these applications now shifted to be connected to each other and hosted in the cloud. And so we had companies like Amazon Web Services or Azure, and their APIs were effectively an operating system for these cloud services. And we believe the same thing is going to happen for spatial computing. And I mean spatial computing in its broadest sense, and that our apps are going to need a set of APIs that tell them about the real world. These apps are going to live outside our device. They're going to live in between, my device and your device. And so the only way that these apps are really going to be able to execute in a way that is a meaningful user experiences is if the application software can call an API and say, look, tell me what is reality. Give me reality so that I can then do my thing in reality. And so those APIs that serve up reality start to look like an operating system. And that's really, from a product point of view and a technology point of view, that's what 6D's orienting towards and what we're trying to build. And really, I think what the trend that we're betting on is not just the fact that us at this type of event are excited about this and have been for a long time, but I've been working in AR for 10 years, in mobile infrastructure for 10 years before that, and in like wireline and dial-up before that. And I've never seen a time where so much money has been invested by all the big platforms, and the CEOs of all these big companies are going out there, backing betting their companies on it, before it's actually started to work. That didn't happen in smartphones until after the iPhone. It didn't happen in the web until sort of after Netscape. So it's exciting to see this happen. Where we're seeing, like, whatever, Tim Cook and Satya Nadella and Mark Zuckerberg talk about the next platform. Platform, what that comes down to is like, what are the apps accessing to learn about the world. So that operating system or those APIs, that is the platform in practical terms. So it's not some sort of vague server that's out there. And so what's interesting about this platform for spatial computing is that it's a hybrid. It's not like iOS that just runs on your phone. It's not like Amazon Web Services that just runs in the cloud. It needs to run on both. There needs to be an aspect of this capability that runs locally on the device, whether it's a headset or a phone. And that's important because the user experience is so real-time and so sensitive and so tightly connected to our sensory experience of the world, is that the round-trip latency on a network just can't exist. At the same time, we need to manage privacy, and that can't really work if that camera data needs to go back to the cloud and be processed by someone else. So it needs to be dealt with on your device. But at the same time, for the app to understand the world, you need a one-to-one scale model of the whole world. You need these models and these data sets that are bigger than can be held or can exist on one phone. Things that if all of us in this room wanted to share some AR experience, a big part of that experience would have to live outside the phone just for us to be able to share it. So I think for the first time, we're going to see a broad platform that is a hybrid solution. So it's not just an AR cloud that needs to exist. It needs to be on device as well. One of the challenges, I think, that I've learnt only by making this mistake in previous companies is how do you figure this out? Like, how do you figure out what these APIs need to be? How do you build an application? What should that application be when I don't know what the APIs are? And there's this tension between, do I build a product first, like Facebook did, like they built the news feed and then they opened up Facebook Connect, or do I try and build a platform first, like build an operating system or build some infrastructure? And neither of those really work for AR. If you try and build the full stack, you really end up where you're chasing your own tail, where you come up with ideas for the product and then you try and build the technology and the technology doesn't work, and then you end up trying to change what the application is. And that, it's kind of a trap, I think, to fall into. And at the same time, we've seen so many like SDK companies just sort of build a set of tools and throw them out there and just hope developers will figure it out, and that doesn't work either. So for AR, I think where the market's at right now, it's neither of those scenarios. You need to do something in the middle. And for us, we're really trying to figure out the answer to, or find use cases, find products that fit all of these scenarios. And we need a technology that actually works, works well enough for a consumer. We need use cases that people are actually going to use, and we need a market that's big enough to sustain someone's business. And so many AR experiences or AR ideas today, fit into only two out of the three, not all three. So, so we're trying to think through, okay, when we look at these APIs that we need to build, what are the use cases, and then is there a big enough market? And the way we're going about that is looking at these verticals and then finding a partner, a big, important, high-profile partner that really understands the problem from their point of view, and then getting in close with them to work on it. So the funny thing is, as we've done this and we've started to get interest and get customers doing deals with us, is that the use cases are really obvious. They're the same use cases we've been talking about here for 10 years. It's like field service, engineering use cases, remote support, it's inspections of properties and of factories, it's previewing CAD models on site, it's sorts of entertainment experiences with virtual characters, it's OEMs wanting some new bit of technology to show off a capability of their product that their competitors can't do. It's how do I find my way around a theme park or even just down the street? And the challenge has been that the use case is obvious, but the user experience is almost impossible because the technology just hasn't supported it. And so as we're looking at 6D and what these apps need to be, what these use cases need from a technology point of view, is that it's kind of a stack that we need to build up from. And we've come at it from starting with technologies like relocalization, which is a way for a device to kind of recognize the room that it's in and get the coordinates of that space. And if think like Kevin and Charlie were talking about, if that's crowdsourced and those coordinates are persistent and shareable, then everyone can share in that experience. But then once we're in that, we now have problems where we need occlusion and we need physics and we need things interacting. So then on top of that, you need to start building this meshing and geometry layer. And that's only ever been possible in the past with depth cameras and like special hardware that just wasn't widely available. So you really need to be able to do that on like mass market commodity devices. Then when you've got that, you start to get problems about understanding what these meshes are. Like humans can't quite make out what, is that a couch or is that, who knows, is it a table? So we need to be able to make them recognizable to machines, separate the meshes out into, using artificial intelligence. And then we start to understand bits and pieces of the world. And then you start to run into this problem of like the world's not static. Stuff's moving all the time. And again, Kevin referred to that where we need to, as you look at the world, you basically need to be able to perceive the world in real time and understand and serve that up to the application so that if you walk in front of some piece of content, like a couch you're previewing in your living room, the system should be able to tell the application, look, there's a person here, so don't draw the couch, where that person is. And it'll look like you're being occluded. And at the same time, you need constantly to be working on performance, scale, and by scale, I mean things like if you work with AR Kit or AR Core today, if you try and build an experience that's bigger than kind of a living room, it kind of breaks. So you need to get to like big buildings and then outdoors and city and world scale experiences. And then you need to be able to get that type of experience onto all sorts of devices. Not just Android and iOS and headsets, but eventually robots and drones and VR headsets and pretty much any type of product that needs to have its software function out in the world somewhere. So this is basically our plan, 12-month plan for what we're building. A lot of this stuff, I'll show some demos of this stuff working now. But it's exciting that as we're working with customers, we're starting to see this stuff actually start to pay off in applications that will be announced and launched later this year. So we've taken on the role of solving these technical problems. We've taken the approach of partnering closely with people that have wrestled, application developers who have wrestled with these problems and have got some scale. And eventually we'll sort of push this capability out in an easy way for all developers to be able to work with. So if we look at what are today's most technical challenging problems, there's more than this, but these are the ones that we're kind of looking at, and I'll show you, some solutions now. But the first is 3D reconstruction and meshing just on a regular phone. That's important because it is that first example of a digital twin. And it's the first time that you can start to capture that digital twin as your camera basically sweeps across. It's completely natural and it just works. Second is then to get that to world scale. Like how do you get beyond just capturing a small little area and getting that to work on large crowdsourced models where hundreds, thousands of people can be out there with their phone. You can start today, finish tomorrow, and just that model just builds and builds and builds. Then how do I come back to somewhere and just figure out where I am and get everything that was previously captured in that space and you just get that to automatically download and be usable by the application so you don't have to like rescan over and over and over again. Then we get into some of this on-device segmentation. This is some of the real-time moving objects detection. And I point out that on-device is critical, and I'll show you why that matters from a privacy and a user experience point of view. And lastly, we talk about cross-platform privacy. And this is, I think, something that we've been hearing at 6D where we thought that our tech would be the cool thing that everyone kind of gets excited about. And it gets attention. But what actually gets them to get their checkbook out is when we can say, look, we can work cross-platform and we can manage your data in a way that's private and appropriate for you. And no one else can do that. Like, none of the big companies can do that because their business models kind of prevent them from it. So here's a first little example. This is just running off an iPhone. This is a home of one of our engineers. And really as fast as he can walk around that house, he starts building a 3D model of that house. So this is the sort of stuff that used to need something like a Tango or a HoloLens or some sort of device with a depth camera to do it. But now we can sort of scan, I don't know, we've gone up a bit over 5,000 square feet, literally as fast as you can run around and build that model. Now the magic thing about this from our point of view is traditionally the model has been a different kind of data, different piece of data from the SLAM system. It kind of just uses the SLAM system, but builds the model separately, and the model is basically just a visual representation, and that's it. But the way we've come at it is that the model and the SLAM map are one and the same thing for 6D. So it means that the coordinates of that that model are the coordinates of the real world, and so you can then take that model away and author your content inside it remotely, and then any assets that you kind of drop into that scene will appear in the real world where they are. So the virtual and the real are effectively one and the same thing in the way they behave. So the next one is kind of cool. This is how we crowdsource the world, and this video is we just released a new update yesterday. And what this shows is, I think, 4 of the guys in our team all wandering around our office at different corners of the office, and then they all upload their mesh, and that mesh just gets merged into a single map of the office. And so for a 5,000 foot space, I think it took them 3 minutes of scanning and then 7 minutes of processing, and we had this. So this is all the phones as they're walking around, seeing everything get built in real time. And so you can kind of get a sense of what the office looks like here. And then at the end, you'll just see, we get that. At the end. That literally was less than 10 minutes to build a model of that size. So thanks. And that showed like 4 engineers, but there's really no limit. We were sort of curious. So if anyone's interested in pushing this thing to the limits, and you've got like 100 volunteers to go out and try it, we would love to just see how big a space it can capture. But in terms of the way the system is designed, there's no sort of design limits or anything on that. So we could capture, we're working on a project that's like a 4 square kilometer site, and this will support that. So the next thing is, once you've got that model, like what happens when you come back tomorrow? You don't want to scan again. And again, this is sort of, from a user experience point of view, it's important that this stuff just works. You don't want to have to type in the room number that you're in, or put some special code, or worry that you uploaded it, so I can't access what you uploaded it. And it just needs to happen. So here, when this one starts, it's literally the same app that you just saw that did the capture, and it starts up, and then as soon as the phone moves, that's when we start the relocalization process. And that means we capture part of the scene, we query that to our servers, and then we pass down a bit of a bit of matching data, we run all the processing on the phone, and then we download the mesh of the office. And the mesh, after the fusion happened, is about 40 megs. So you'll just sort of see how quickly this happens. So, so it starts kind of now, just download a little bit, we start relocalizing, and 2 seconds, and we now have 5,000 plus square feet of space. And again, as you start walking around from that point, it will just start extending that mesh and continuing to contribute and crowdsource a bigger and more accurate model of the world. So all this stuff kind of runs just in the background of the app. Like, we're showing it here because it's our test and demo apps, but this could all be happening invisibly to whatever it is that you've built, and your users, it's not impacting. They don't have to like pause and do some scanning and then go back to their app. It all happens in the background. So now we've got a nice static model of the world that's big and accessible and crowdsourced and repeatable, but there were no people in any of those scans. So the thing we're working on now is to merge all of that stuff with this next video, which I shot at Coachella this year, and this is running on device, and it's detecting people in real time. And what this means is that, well, I'll get to the next slide, I'll just let it run. So it's currently you can pick out about 100 people at a time. This is an early version. It's gotten faster and better and more accurate since then. But the sense is, it draws like a red mask around someone every single frame of video. And when it finishes, so what's important about this is that privacy is dealt with on the phone. We don't, take a shot and then put it up to the cloud and then sort of go through and blur everyone's face. We don't have to, we don't even process it on the phone. So everything in red won't even get sucked into our system. We just ignore it from the beginning. So it's completely, completely private. There's nothing to even obscure. It also means new use cases start to become available. We can do occlusion of AR objects. So you can have a virtual object and people walking around it, and when people walk in front of it, behind it, it'll behave appropriately. And that's only possible if you have depth and the segmentation and merge them together, which has never been done before. It also means you can do diminished reality. That means that we could take everything that's in red and basically redraw the background over that, and that person would effectively disappear. That's great if you're trying to take a video selfie or an Instagram story at the Eiffel Tower and you want to get rid of the pesky tourists. It's bad when you want to just start erasing people from your field of view. And then under the hood, it gives us a bunch of benefits because we don't even, our maps and our meshes, we just ignore things that are likely to move. And so they're more reliable, they're higher quality, they're more precise. And as I implied, it does raise some new ethical questions that aren't hypothetical anymore. So working in AR, a lot of the privacy and ethics questions are scary and hypothetical and science fiction, imaginary sort of stuff, but we're now kind of finding that some of these are becoming real. Like when we expose these APIs, it's the same API for the good stuff or the bad stuff, and so how do we think about that and approach it is no longer hypothetical for us. So that's been fun. And as I implied before, one of the things that's, I guess, we're enjoying in the market right now is that we're able to deal with these two requirements that, ironically, the bigger the customer is, the more high profile that customer is, the more they care about this. It's not something that's sort of your indie, open source, sort of whatever advocate sort of cares about. It's actually, these big Fortune 500 multi-billion-dollar corporations are saying, look, we don't want to build an iOS-only app. It has to work on everything, but we don't want to give our data to, some of these companies with advertising business models because we're not really sure what's going to happen down the road. So we find that's very critical. So I was fortunate to pick one of Kevin's quotes, but this stuff's really important. It is going to be the platform, these APIs, whether they're ours or from someone else, these are going to be the platform that unleashes thousands and thousands of apps, and everything is going to be built on top of it. So just want to say thanks. We're really trying to work on this stuff, not just in a science fiction sense, but in a very practical terms, and I would love to open up for any questions for anyone. So. All right. Okay, easy one. When will we support Unity? We already do. So that's working great, and we have a lot of friends at Unity, and we're working to make that integration and support even better. What dimensional accuracy do we get from the mesh? The off-the-shelf SDK right now, the resolution is about 2.5 centimeters, for a voxel, and then we sort of decimate that. We found that's about the right trade-off to be able to scan really large spaces really quickly. We found that trying to do like a 3D scanner that scans like for asset creation and like these nice high quality models, like that's not the business we're in. Like take your time, spend an hour, do the scan like really high quality with a depth scanner. For us, it's like if you want to capture this whole room and use it to build an AR experience in this hotel, that's something that really we can do. Once you build the technology, how do you think about world user interfaces? Yeah, it's it's a problem we're staying away from. There's better people to solve that problem than 6D. We are obviously, the interface, the user interface is going to be heavily enabled and constrained by the hardware form factor and the sensors in that hardware, and that's something we've got no control over. Our ambition, I guess, ends where you serve up reality. We just want to be able to tell this system, here is reality, and then if you're wearing glasses, the user experience will be one thing, or the interface will be one thing. If you're on a phone, it'll be something different. If you're trying to program a drone to move around that space, it'll be a different interface again. So, it's kind of like we don't want that to be our problem. As a developer, the current market is whack-a-mole. What would be your recommendation to keep up or pivot quickly? Build on us. We'll stick around. It is hard to keep up. Yeah, I don't really know. Like at different levels of the technology stack, the research is moving so fast, let alone the products are moving fast. Generally, I'd say, first of all, try and find an SDK, whether it's AR-Kit or AR-Core, that just gives you 6 degrees of freedom and a camera background and a simple plane to build on. And then move to something that actually gives you a 3D mesh of the world, whether it's like Magic Leap or HoloLens or us. Because as a developer, the hard problem isn't like today's feature or tomorrow's feature. It is just, how do I build an app that will run when the app doesn't know what the world is going to look like? And so trying to figure out all those user experience things and the use cases in the market and how that works in a spatially mapped environment is the problem, much more than whether it's our SDK or Magic Leaps. It's just start getting some experience. What new phone sensors or capabilities would be most useful? So, interesting. Like the obvious answer there is a depth camera on phones, but that's not actually the right answer. That just makes things a little bit easier. It's not a silver bullet that solves things. What we're finding we're constrained by is just literally the neural network and GPU processing capabilities on phones. And they are like every phone, they get 10 times faster. So it's, we always want as much as we can get of that, but fortunately it's happening so fast that it's good. And the software itself, like we went from, this time last year, our system ran at about 3 frames per second on an iPhone X. And in our labs now, we're running at about 25 frames per second on an iPhone 6S. So that's more than like 10x sort of performance speed up just on the software. So everything's sort of compounding. Plans for a web-based SDK. Hopes and dreams more than plans. We're looking for a customer who really needs it. There's a lot of this stuff we could get sucked into trying to boil the ocean. We're very focused on those use cases and what these actual customers really need, and lots of people say they want it. No one's sort of willing to say, yes, my business actually needs it and I can justify some investment around that. We always ask for a lot of money for what we're doing. Revenue is great, but not so much because we need the cash, but it's a way to filter out who's actually serious and who really needs this versus people who just think it's cool. So that's kind of what we're waiting for. Android support has been something we've been on the verge of for a long time, and this time it's really going to happen. We've been demoing it for OEMs for a while we've worked to get off of OpenCL. That work to get off OpenCL has been going really, really well, better than expected, and so I think we're at the point, sort of early next month, we'll shift from sort of getting the technology to work nicely to how do we package it up for distribution and how do we make it available on as many phones as we can. So that's nice. Can we handle different privacy permissions? Not at the moment. There's a whole fascinating, huge problem around private clouds and private meshes and different degrees of ownership and how do we segment things up. And no one really knows answers to that, and we're figuring it out as we go. My time's up. There were more questions. Sorry I couldn't read them, but thank you, everyone. I'll be around. I can show you demos.